Welcome back to the morning show. It is Wise Guy Wednesday, and with us is our resident mad scientist, Matt Sullen. Matt, thanks for coming in this morning. Now, we've been talking a lot over the last couple of weeks about hurricanes, with, of course, Katrina and Rita, and a lot of people have kind of developed an interest in these storms and how they work and why they do what they do, and you're here to help us explain a little bit about that.
Right. I went back to my undergraduate atmospheric science textbook to learn about this stuff, because even though that was a long time ago. Hurricanes are fascinating things, and they produce and use an enormous amount of energy, and we'll talk about that later. But the thing that fuels them, all this energy, which is huge amounts, many thousands of atomic bombs worth of energy are in one of these storms. Basically, it all comes from warm water.
Right. We talk about how the storms really develop over the warm waters of the Gulf and the Atlantic and the Gulf Stream, and then die instantly when they hit land.
Right. And so what happens is that if the waters are 26, 27 degrees C, which they evidently are now, then you have sort of ripe conditions for formations of these things. And so what happens is the water, it turns out, is a great place to store energy. And so you can show this. Here I have a little hot plate and I'm boiling water. You can see it boiling. And if you zoom back, you'll see that, you can see the thermometer here is going to be at about 100 degrees Celsius.
We're talking Celsius.
Celsius, exactly right. And so you can put heat into this water for hours and hours and hours, and the temperature isn't going to go up. All you're doing is making it boil. So all the energy, all the electricity that comes through this cord, which is a lot, that goes into this hot plate, goes into turning water from a liquid into a vapor. And so that energy is stored in the vapor, and you get it back when the vapor turns back into a liquid again, when it turns into rain, for example.
Okay.
And so what happens is, over the ocean, you have this warm, moist air. Winds blow in and sort of push the warm, moist air upward. As it goes up, it cools off, and the water comes out of the vapor phase into the liquid phase again, and that's the rain that you see falling out of a storm.
Right.
And that energy then is turned into energy that's usable to make winds move and water move and things like that. So, it
makes the switch from vapor to water, all the heat energy that it's sucked up here is then re-released.
Right. So a lot of energy is used to make the water into vapor, and that's released when it goes back from being vapor into being rain, for example, in the storm. So all that energy can be used to drive the storm even higher into the atmosphere, to make the pressure a little higher, make the air expand a little bit, and so you can get this sort of motion of upward in the center, and then the rain falls down, and you start these convection currents.
Now, you were telling me off camera before we started that one hurricane contains as much energy, if not more energy, than human beings have produced.
Well, right. So it's basically thousands of times the electrical output of the Earth is the amount of energy that comes out of a storm during the time that it's going on. And then basically these hurricanes produce something like 100 cubic kilometers of rain. It says in trillions and trillions of gallons. I mean, it says mind-staggering.
Convert that to miles, like 25 cubic miles. Right. Think about that. 25-mile cube.
Right. And so anyways, so warm air rises, and I wanted to show that because that's key to all this too, because the moisture that's released causes the air to get a little warmer, and it rises a bit further. So I've made this balloon, and I kind of like this because you can do this at home. This is just sort of a hair dryer, and this balloon is made from a dry cleaner bag, and so I'm just going to blow some warm air into it, and you're going to see that.
This is how we get the storm clouds to rise.
Right, and so this just shows that warm air tends to rise over cold air.
Okay, well, so the next time we get together, we're going to talk about storm surge and how that all works.
Right, the storm surge and so on, and what that happens, or what causes that. Exactly right.
Okay, Matt, we'll check in with you again in the next half hour of the morning show. I can't see through the dry cleaning bag, but we'll be right back.
It's got a ghosty on it.
Oh, it is time for weather, isn't it? It is 6:53. Time for Storm Tracker weather here on the morning show.